Hi, my name is Vivek Ramurthy. I am from Informatica Global Customer Support. Today we will be discussing on system troubleshooting. And agenda of this video is to talk on basic idea on system troubleshooting, need of system troubleshooting, commands which all are helpful, their usage and syntax, and few examples on commands. Let's talk on the basics of system troubleshooting. Here we need to figure it out what was the startup time of the server. That means since when the server is up and running, how much disk space is being used right now and how much disk space is available, CPU utilization, memory utilization, ports usage, disk input output, and number of open files on the server. Let's talk on what is the need of system troubleshooting. We have seen sometime a particular process is hanging, a process is using high CPU, high memory, or the disk space on the server is very low, or very low input output. System is not responding. Because of these, we can see a number of issues on the server machine, like server will not be responding to any process. For example, we can see that a process is hanging, and if you will try to ping that process, the process may not respond. So we need to figure it out why the process is hanging or where it is stuck. We have also seen some scenarios like a particular port is being used, and we try to start a service, and that service needs a particular port to be available, but the port is not available, because of which the server will not be able to start the process on that particular port. So we need to find it out if the port is available or not. We can run some commands. I have also seen some scenarios where disk space on the server is low, but I mean the disk requirement for a particular process to start is, for example, we need 500 MB of disk space, but available disk space on the server is around 100 MB. So in that case, we will not be able to start the process. The process may not throw an error message, but it may go down. These are few important commands which we will discuss today. The first command is uptime, which is also called as load average. The next command is free, top, iotop, vmstat, iostat, prstat, netstat, lsof, pmap, lscpu, nmon, sar report, and gcore. First command of our discussion is uptime. It gives a one-line display of following information: the current time, how long the system has been running, how many users are currently logged on, and system load average for past 1, 5, and 15 minutes. Syntax of this command is uptime, and I ran this command in my server. You can see the output here. It is showing the current time of the server, and the next one it will show since when the service is up and running. Here from last 51 days, 10 hour 39 minute, the server is up and running, 2 users are logged in, and the load average for past 1 minute is 0.25, past 5 minute is 0.04, and for last 15 minute is 0.05. Second command of our discussion is free. It gives total and available physical memory on the server. It also gives information on swap memory with buffers used by kernel in Linux or Unix like operating systems. The syntax of the command is free. When you run the command here, you can see that the total memory available on the server is 8011 megabyte, out of which 5425 megabyte is being used, and free memory is 781 MB, and out of swap memory, total swap memory is 524. The syntax of the command is free. When we run free on the server, it will give us the total memory, which is 8011 MB, out of which 5425 MB is used and 781 MB is free. And on the swap memory, you can see the total swap memory available on the server is 5242 MB, out of which 589 MB is used, and free memory is 4653 MB. The third command we will discuss is top. The top command can be used to display system summary information and current utilization on the server. It gives us the information on uptime, tasks, CPU usage, memory usage, swap memory usage, and process list. The syntax of the command is top. We can also run top command with some options and save the output to a file. For example, here you can see that we can use option top hyphen D, which is for delay, and hyphen N is for number of iteration, and redirecting the output to top.out. So when we will run this command, it will collect top. For example, if we are giving delay for 30 seconds and number of iteration as 2, the top output will be collected twice on an interval of 30 seconds, and it will be stored in top.out. We will see the output in the next slide. This is the output of top command when I ran on my server. Here you can see that the first information it is giving about, that is the top, and it gives us the information on uptime. You can see the time on the server right now is 18:45, and it is running from last 15 days. 2 users are logged in, and the load average for 1 minute, 5 minutes, and 15 minutes are 0.02, 0.04, and 0.05. This also gives the information on task, like how many tasks or process is being ran on the server. Here you can see total 172 tasks are running, out of which 2 are running and 170 is in sleeping state, 0 is in stop, and 0 as zombie. The percentage CPU you can see here. The percentage memory, or the memory in KB, is this much, that is 8011 MB, or 8011.568 KB memory is the total memory, out of which 779 MB is free and 5426 is used. In the swap memory, we can see that 5242 MB is total swap memory, out of which 4653 is free and only 589 MB is used. Here it will give us the process list. You can see for the top processes running on the server, I can see the first process is a Java process, for which the process ID is 3730. The user being ran is root, and the CPU percentage is 1% CPU it is taking, and memory 10.2% of memory this process is taking. Fourth command of our discussion is IO top. It gives a top like utility for disk input output, which needs root permissions to run it on the server. It also gives the current input output usage by processes or threads. The syntax of the command is IO top. When we run this command on the server, it will give you the output like seen. You can see the output. It gives the total disk read, actual disk read, and it gives the information on the user, disk read, disk write, swap in, input output, etc. The fifth command is vmstat. It gives information about processes, memory, paging, block input output, traps, disk, and CPU activity. The first report produced gives average since the last reboot, and the additional reports give information on a sampling period of length delay. The syntax of the command is vmstat. It can also be used for giving some delay and the number of iteration, and we can also save the output to a file. For example, here I have used vmstat 2 space 3, and I am redirecting the output to vmstat.out. Here this command will collect 2 second interval I am providing, and 3 iteration. So the output of this command will be like, it will give us the output of vmstat 3 times in interval of 2 seconds. The sixth command of our discussion is iostat. Iostat stands for input output statics and often used to diagnose performance issues with storage devices. You can monitor CPU, device and network file system utilization report and with iostat. The syntax can be iostat. We can also give some interval and the number of iteration. For example, here I have given 2, 3 and I am redirecting the output to iostat underscore pid.out. This command will store the iostat output for 3 times in an interval of 2 seconds. The output from my server is like this. You can see it gives the information on the type of server and number of CPU and the bit mode of the server, and this is the output of the iostat command. It gives the information on device SDA and bulk read per second, bulk write per second, etc. The seventh command is prstat. This command is similar to top and available for Solaris environment. Very less system admins are using it. It gives the information on CPU usage stats across global and non-global zones. It also summarize about top users consuming our OS resources. The syntax is prstat and the output can be achieved like this. You can see in the screen. For example, it is giving the process ID 7525 and the process is Kherna and the size is 1102 MB, and this process is sleeping right now, and you can see the process. It is a Java process. The eighth command is netstat. It displays network connections, both incoming and outgoing, routing tables, and a number of network interface statics. The syntax of the command is netstat. We can use multiple options with it, like netstat-a, and in the output I can see you can see that I have used multiple options. The command is netstat-anp and I grep on a port number 18080. You can see the output. It's a TCP6 and the port number, and you can see it is listening, and we can see the Java process 3983 is running on this port 18080. Now we can use netstat command for multiple operations. For example, if we want to check if a particular port is being used or it is free, we can run command like netstat-a and grep on the port number. If it gives any output, then it means the port is being used by any process. If the output is blank, that means we can think that the port is available. The ninth command of our discussion is lsof. It gives the list of open files. It also gives which files are opened by a particular process. The syntax of the command is lsof. We can run this command on a process ID to see which all files are being opened by this process. The syntax is lsof -p and process ID and redirect the output to a file lsof.out. You can see the output. I ran a command on the process ID 54526. I can see that the files it is taking the file from /home/ro jaswa directory. Our 10th command of our discussion is pmap. It displays the memory usage map of a process or multiple process. It also gives the address space or memory usage map of a process. The syntax of the command is pmap space the process ID of the process for which you want to see, and you can redirect the output to a file. Here I am redirecting the output to pmap.out, and I ran the command as pmap and the process ID 5 to 6. The output of the command can be seen as the process. It is being used by SFTP server, and this process is taking 40 KB from this location and 2044 KB from this location. The 11th command is lscpu. This command gives CPU architecture information from sysfs and /proc/cpu info. It gives the number of CPUs, threads, core, sockets, and non-uniform memory access nodes. The syntax is lscpu, and when you will run this command on the server, you will get a list of all the CPU information. For example, CPU architecture, if it is 64-bit or 32-bit, CPU operating mode, byte order, CPUs, number of CPUs. Here you can see it, we have 32 CPUs on the server. Now when I run the command lscpu on my server, it gives the information like this: architecture, CPU, operating mode, byte order, CPUs. You can see it has 80 CPU, threads per core, core per sockets, 4 sockets, CPU family 6, model name, stepping, CPU, megahertz, and a few more informations. The 12th command of our discussion is nmon. Nmon is a computer performance system monitor tool for AIX and Linux operating systems. It has two modes. First, displays the performance stats on a screen with a condensed format, and the second one, the same stats are saved to a file for later graphing and analysis to add the understanding of computer resource use, tuning option, and bottleneck. The syntax of the nmon command is like we can directly run nmon and provide the input options like MD, T, V, etc. to get memory, disk, top, and virtual memory utilization usage. The second mode for the nmon command is like we need to specify -f so that it will record the output to a file. For example, here I have used nmon -f -s10 -c30. It will generate a output file with named as hostname/timestamp and .nmon, and -f is to record the output, and -s is to capture data every mentioned as seconds, and -c is to capture the data points or snapshots. So in output of this command we'll have here let's take an example of nmon command. I am running nmon. You can see the output. It prompt term new window where we can see the CPU. We need to type C to get the CPU statics, M for memory, D for disk, F for resources, and kernel. A few more options are there. Let's proceed by typing M. You can see I'm getting the output for memory stats, where total RAM in MB available is 515683 MB, out of which this much is being utilized. Here I am running nmon with -f, -s10, and -c30. It will generate an output file. Here you can see that I have run the command, and it generated an output file named as the host name, that is inglx72, and the timestamp and the .nmon. The output .nmon file can be opened in any nmon analyzer utility outside. 13th command of our discussion is SAR report. SAR means system activity report. It is helpful in collecting a number of reports including CPU, memory, and device load. By just executing SAR command will show system utilization for the entire day. By default it stores utilization report in 10 minutes. If you need something sorted in real time, we can use the command as below: SAR interval in seconds and number of times or number of iteration we need to collect the SAR output. For example, here I have shown used SAR 30 space 3. It will show the output for every 30 seconds 3 times. We can also store the output of a SAR report to a file. You can use SAR-A and redirect the output to SAR.out file and share the SAR report with us. 14th and the last command of our discussion is gcore. It generates a core file on a running program. The syntax is gcore-o output and space process ID on which you want to generate a core file. We can use this command in a scenario like a particular process is hanging. Instead of generating traces, we can generate a core file on the hanging process, and later once the core file is available, you can use pmstack command to collect traces on the core file and share the output with us. Thank you for watching the video.